Okay, in this video we're going to be doing assignment 8, or the beginning of it, from my Calc CD class, Multivariable Calculus. We're going to be sketching a region. We're going to use polar coordinates. These are going to be double integrals. So we're doing double integrals in polar coordinates. Let's see what the problems look like. So here we have f of xy is the square root of x squared plus y squared. If you see a lot of x squareds and y squareds in your problem, you're probably going to want to use polar for it. That's like sort of a visual cue that polar is the way to go. So f of xy is the square root of x squared plus y squared. And then the region is going to be bounded by x squared plus y squared is less than or equal to 2. I think the thing we want to do in almost all these problems is start off by drawing the region in the xy plane. So remember, you don't need to know what f of xy looks like. You need to know what the region in the xy plane looks like. So this is going to be a circle that has a radius of the square root of 2. And then what we want to do is from this figure, we want to figure out the bounds for r and the bounds for theta. So r starts at the origin and just goes out until root 2. So we're going to get this, 0 less than or equal to r less than or equal to root 2. To go all the way through the region, I'm going to go counterclockwise, and I just go from 0 to 2 pi. So I have this. I also am going to need to change my integrand, so the function that I'm going to integrate from rectangular into polar. So x is r cosine and y is r sine. I'm going to end up with a function of r and theta. Well, maybe, but I could end up with a function of r and theta. So we're going to use x squared plus y squared is r squared. This is one of the big formulas that you use in polar. X is r cosine, y is r sine, x squared plus y squared equals r squared are definitely the three biggest. And then you also need to know that tan of theta is y over x. In this case, everywhere I see x squared plus y squared, I'm going to be replacing it with r squared. So I will end up with a function of r and theta, or just r in this case. It's the square root of r squared. Since r is between 0 and root 2, r is always positive, so the square root of r squared is just r. Technically, you might need the absolute value of r is sometimes negative, not in this case. So we'll set up our integral. So we're going 0 to 2 pi. So usually with these, I like to go dr d theta. Like that's the order I prefer. Like theta is usually my final outer integral, almost 100% of the time. We're going to put in the integrand, and then we will see the place where people make the most mistakes. It is when you replace, or I guess the differential for polar is going to be r dr d theta. It is not just dr d theta. So it is r dr d theta. If you do a problem and you find that it's impossible or you're getting the answer wrong, it is almost certainly because you forgot that extra r. So it's r dr d theta. This, it turns out, is a product of a function of r and a function of theta. The function of theta is just 1, so like it is a function, but not an exciting function. So we can split this into a product of integrals. So we have 0 to 2 pi of, I forgot to finish the pi there, 0 to 2 pi d theta, and then 0 to root 2 of r squared. So when we integrate 1 d theta, we just get theta, and then plug in 2 pi, plug in 0, we just end up with 2 pi. So this will be 2 pi, and then we have 1/3 r cubed from 0 to root 2. Then we sub in, we get 2 pi over 3, the square root of 2 cubed. When you plug in 0, it just zeroes it out. So you could leave your answer like that, probably. I simplified it. Let's take a look at the next one. So we got a bunch to do in this video, and then I will come back and do, I don't know, like 2 or 3 different videos, I think, for this problem set, because the problems kind of change a little bit. All right, number 2, f of xy is x squared plus y squared. So immediately you're thinking that's probably going to be a polar integral. And then 1 is less than or equal to x squared plus y squared is less than or equal to 4. So definitely this is set up for polar. Let's draw the region. So we have a circle of radius 1, a circle of radius 2, which means that r starts at the origin. Well, here's our region. We're going to start at the origin, go to the first curve, and then start at the origin, go to the second curve. So the closest curve is 1, the farthest curve is 2, so our bounds for r will be 1 to 2. To go through the whole region, we have to go all the way around. So theta goes from 0 to 2 pi, which is actually really common unless there's like more restrictions given. We have to convert our integrand, so f of xy, but it's just x squared plus y squared. So f of r theta will just be r squared in this case. And then set it up, and do not forget that you're not going to just do dr d theta, you're doing r dr d theta. So our integrand is r squared, and then we get an r dr d theta. This again can be split into two integrals, like the integral from 0 to 2 pi of d theta times the integral from 1 to 2 of r cubed. So let's split that, and then we'll integrate. So it's really common to just get like a 2 pi in front because you frequently end up just integrating 1 d theta, and then 1/4 r to the 4th from 1 to 2, and then we plug in, we get pi over 2 because 2 pi divided by 4, and then 16, 2 to the 4th is 16 minus 1 to the 4th is 1, and so we get 15 pi over 2. All right, let's take a look at the next one. We have f of xy is xy. X is greater than or equal to 0, y is greater than or equal to 0, and x squared plus y squared is less than or equal to 4. So since x and y are both positive, we're in the first quadrant. Let's draw that. So here we go. This is our region. It's a circle of radius 2. Don't forget that x squared plus y squared equals r squared is the equation of the circle. So like that thing that you're seeing, the constant, is always r squared. So that's why our radius is 2. You can see here r is going to go from 0 to 2. And then theta, in this case, only goes from 0 to pi over 2. We do have to convert f of xy, right? So in this case, it's not just x squared plus y squared or some manipulation of that. It's x times y. So we do have to remember that x is r cosine and y is r sine. So we'll just end up with r cosine times r sine. So x is r cosine, y is r sine. So this is going to give us r squared, and then you have cosine times sine. I'm going to do a thing that is really common because I think it makes a lot of problems easier. I'm going to use the double angle formula for sine. So sine of 2 theta is 2 sine theta cosine theta, which means sine theta cosine theta is 1/2 of sine of 2 theta. So I'm replacing sine cosine with 1/2 sine of 2 theta. It's just an easier integral to do, like I don't know, like in my head, it's easier. Let's make all of our substitutions. So we are going to have 0 to pi over 2, 0 to 2. Our integrand, which is 1/2 r squared sine of 2 theta. And then there's going to be an extra r dr d theta. Don't forget the extra r. That's the thing you're going to forget. This, and I would say most polar integrals, can be divided up using that property where if you have a function of r times a function of theta, you can break it into the product of those individual integrals. So I'm going to do that. 1/2 constant multiple, pull it out. 0 to pi over 2 sine of 2 theta d theta, 0 to 2 r cubed. So we just have to integrate this. So there's going to be 1/2, and then we'll get negative 1/2 cosine of 2 theta from 0 to pi over 2 times 1/4 r to the 4th from 0 to 2. Now we just have to plug in. So we're going to plug in pi over 2 and 0 for our first integral, which gives us negative 1/4 quantity cosine of pi minus cosine of 0. Cosine of pi is negative 1. Cosine of 0 is 1. And then 1/4, you get 2 to the 4th, which is 16 minus 0. So 1/4 of 16 is just 4. Negative 1/4 and 4 is going to give us negative 1. And then cosine of pi is negative 1 minus cosine of 0 is 1. So negative 2. You have negative 2 times negative 1. You're going to get 2. There you go. That's what we've gotten. All right. Let's take a look at the next one. F of xy, they're just getting more complicated. Y times x squared plus y squared cubed. Y is greater than or equal to 0. X squared plus y squared is less than or equal to 1. Okay, so let's sketch the region. So we get a circle of radius 1. Y is supposed to be greater than or equal to 0. So we just get like this top part. And then the radius is 1. So if we go from the origin to the outer curve, that's 0 to 1. And then our theta values, we just rotate through the region. That's 0 to pi. We have to change f of xy into a function of r and theta. We know that y is r sine theta. And we know that x squared plus y squared is r squared. So this will be r squared cubed. Okay, we're ready to go. As long as we don't forget r dr d theta, the number one thing people forget. So set up your bounds. Our integrand is r to the 7th sine of theta, and then there's going to be another r dr d theta. So again, we can separate this. I use that property every chance I get. It just makes it a little bit easier, I think. You can't always use it, right? I mean, if the bounds for r were dependent upon theta, you would not be able to break this up. If somehow your polar curve was a function, like sine of r plus theta. I don't think that's really possible. That's like a weird implicit thing, but then you wouldn't be allowed to do it either. But here we can. So the antiderivative of sine is negative cosine and 0 to pi. And then we'll get 1/9 r to the 9th. Fortunately, from 0 to 1, so we don't have to raise some number other than 1 to the 9th. We're going to plug in and get negative cosine of pi minus negative, so plus cosine of 0. And then you'll notice that happens a lot. It seems to be the case that you integrate sine more often than you integrate cosine. I don't really know why that is, but it does seem to be a thing. And then when you plug in 1 and 0, you just get 1/9. And then negative 1 is 1, plus 1 is 2, so we get 2 times 1/9, which is 2/9. All right, one more in this video. I lied, 2 more in this video. And then we will do something else. All right, f of xy is y times the quantity x squared plus y squared to the negative first. Y is greater than or equal to 1/2 x squared plus y squared less than or equal to 1. So a little bit different. Let's draw this. So here's like the half of the circle that I need. I mean, I could have drawn the full circle, but since y is greater than or equal to 1/2, we don't need the full circle. So we're going to have this. So there's y equals 1/2. What we need to do for this region is we need to figure out what's going on, right? So here's what we have. We are going to go from this intersection point, which is basically a unit circle point, right? Like if y is equal to 1/2, x has to be root 3 over 2. So this point on the other side is also a unit circle point. It is fortunate that they're unit circle points because it means we know the theta values. So r is going to go from basically y equals 1/2, but y equals 1/2 is not a polar curve, so we got to convert that out to 1, right? So the big radius is 1. The little radius hits y equals 1/2. I need to convert y equals 1/2. So that means that r sine is equal to 1/2, or r is 1/2 cosecant, or 1 over 2 sine if you prefer, which I can't imagine preferring. So that's the inner curve. So r is between 1/2 cosecant and 1. So that's our bounds. Now, the other thing, let me go back. I don't know how far I have to go back. Also, I do not want to start this over. So that's what we have for our r bounds. Now we need to figure out our theta bounds. But theta just goes from these 2 intersection points, right? So we have this, and we're going this way. We know the unit circle points. Root 3 over 2, 1/2 corresponds to pi over 6, and negative root 3 over 2, 1/2 corresponds to 5 pi over 6. So theta is going from pi over 6 to 5 pi over 6. Knowing the unit circle is extremely helpful in a lot of polar circumstances, basically all of them. If you're doing polar, you should memorize the unit circle. If you never bothered to do that, do it. It'll change your life if you're going to keep doing calculus. All right, we have to convert our integrand, right? So we're going to end up with f of r theta. Y is equal to r sine of theta, and then x squared plus y squared is r squared, so we get r squared to the negative first. And we're kind of ready to go. So this is an example where the bounds for r depend on theta, so we cannot separate this into 2 integrals. I wish we could. I always wish we could. Here's our bounds. We're going to put in this thing. We got r sine and then r squared to the negative first. There's going to be another r dr d theta. So this is going to simplify to, you basically have r squared over r squared. So all the r's are gone. We're just going to have sine of theta. Okay, the antiderivative of sine of theta dr, right? So the variable is r is going to give us sine of theta times r. So here we go. We have, these are our bounds, and we're going sine of theta times r. R is going from 1/2 cosecant theta to 1. I really should have written r equals. I'm color coding, so it's not as bad, but like generally I would like to see r is equal to 1/2 cosecant to r is equal to 1. Just so you know what you're plugging in for, right? Because you could screw up and plug in for theta accidentally. It'd be weird to do that, but you could. All right, we got to plug in. I'm just going to make it look ugly. I'm going to do the quantity 1 minus, right? So we have this. So I've plugged in for r. I plugged in 1, and then minus I plugged in 1/2 cosecant theta. I'm going to distribute because it's the only way I can think to do this. So I've distributed sine of theta, and sine times cosecant is 1. So I get sine of theta minus 1/2. I'm going to find the antiderivative of both of those. That gives me negative cosine minus 1/2 theta. And then fundamental theorem this thing. So we know the if you look, our ordered pairs tell us the cosine of 5 pi over 6 and the cosine of pi over 6. So the cosine of 5 pi over 6 is negative root 3 over 2, and of pi over 6 is root 3 over 2. So let's just plug in. That's when you plug in 5 pi over 6. This is when you plug in pi over 6. And then when you simplify that, you end up at root 3 minus pi over 3. All right, I got one more in this video. This is a very long problem set. There are like two that are really long. One is the polar one, and the other one is the one about line integrals. I'm not looking forward to recording that one. I wasn't really looking forward to recording this one either, but here we are. So one last problem in this part of this problem set. We got f of xy is e to the x squared plus y squared, so e to the r squared. And then x squared plus y squared is less than or equal to capital R, which is like the most annoying thing in the world, which means that the radius is square root of capital R. So you keep having to say capital R. Could have chosen any other letter in the world, but we're using capital R. All right, so our circle is this. It has a radius of square root of capital R. Our radius goes from 0 to square root of R. So we got that. Theta goes all the way around, right? So theta goes from 0 to 2 pi. Our integrand, we already said, right? You start to get used to it. You see polar everywhere. F of r theta is just going to be e to the r squared. Set it up. Our integrand is e to the r squared, but there's an r dr d theta. That r is really important in this particular case because without that r, you couldn't integrate e to the r squared, right? You need r e to the r squared for the u substitution. This we can break into two integrals, so we will. There's going to be 0 to 2 pi of d theta, and then 0 to root capital R of r e to the r squared. Let's integrate. So the d theta thing, again, just gives us 2 pi. And then this will give us 1/2 e to the r squared, 0 to radical capital R. 1/2 times 2 pi is just pi. And then you plug in the radical thing and you get e to the capital R. You plug in 0, you get e to the 0, which is 1. So quantity e to the capital R minus 1. All right, that is the end of this part of this video. I will be back in the next part to continue. I hope this was helpful, and good luck.